Alright, so today let's talk about area. Area is the measurement of the number of square units inside a figure. If you look at the board here, I've created some sort of non-polygon figure, but I've also put in squares of some unit. If I count them, I have 1, 2, 3, most of 4, so maybe these two we'd call 4, and here's a little bit of one, maybe 4 1/3 square units. Again, area is measuring how much space is inside by some given unit. If we start with polygons, there's some basic formulas here. Again, most of these should be reviewed. Our favorite polygon probably is a rectangle. A square is a type of rectangle too. Remember, a square is just equal sides. A rectangle is 90-degree angles and has each side opposite are parallel and the same length. Parallel and the same length. And the area of a rectangle is simply the length times the width. And that will give you the number of square units. For a triangle, here I've drawn a right scaling triangle. 3 different length sides, a right angle, so it's a right scaling. And the formula for this, you can picture almost coming out of this rectangle. If I draw this in here, how much of the rectangle is there? 1/2 of the rectangle, or 1/2 base times the height. But we must realize the base and height need to be perpendicular. And I've drawn 2 of the triangles here where I copied the base and I kept the same height, showing the dotted lines across. And the base times this height is the same formula. So this triangle and this triangle have the same area. And this triangle, and this triangle have the same area. Again, you simply have to find the perpendicular, the height that is 90 degrees. It does not have to be in the triangle. If it's a right triangle, they will both be legs. But in an obtuse or an acute triangle, the height will not be a leg of the triangle. So let's try a composite shape. I want to find the area of this shape. And I've drawn the shape here on the board. The first step is always to identify what are the basic shapes in there. Well, I have a triangle and a rectangle, which I drew on the board. And I'm going to dimension this now in green. For the triangle, you have to see if the base is 4 here. The dotted line up here needs to be 4. So I have a 4 here. And the height inside the triangle was given as 4. And those are both in inches. Well, now I can use my formula. Area of a triangle is 1/2 base height. The base of this triangle is 4 inches, and the height is 4 inches. 4 times 4 is 16. Inches times inches. Inches times inches is inches squared. 1/2 of 16 is 8, so I have 8 inches squared. The rectangle is going to have the same width, 4 inches, and its height on the board is shown as 6 inches. Area of a rectangle equals length times width. And this is what we're doing. We're doing step 2 right now. We're calculating the area of each. 6 inches times 4 inches. 6 times 4 is 24. Inches times inches, inches squared. And now, because the units are the same, these are like things. 8 inches squared, 24 inches squared. So I simply have to do the sum. And they have to have the same units. Otherwise you can't add them. They wouldn't be the same type. 8 plus 24, 32. Inches squared plus inches squared remains inches squared because we did not multiply. And the answer to this composite shape is it has 32 square inches. Meaning if I was to sit and divide it into little squares, 1 by 1, all the way through and took all the time to do it, there'd be exactly 32 of those squares inside the figure. So what about shapes that aren't polygons? And basically it comes down to there's a formula for just one of these. Circles. And a circle, again, is a center point and all the points on the outside are equal distance. They are 1 radius away. And the area of the circle is given by the formula pi times the radius squared, or pi times radius. So again, if we do an application problem of this, we'll put it right into a composite shape. I look at my composite shape, and the first thing is to identify the shapes. Shapes I see are a triangle, a rectangle, and half a circle. And the next thing I usually do is I write down the formulas. 1/2 base times height, plus length times width, plus area of a whole circle is pi r squared, but I don't have a whole circle, I have half a circle. Well, now I just simply have to identify dimensions. If I do that, here's my rectangle, right here, 5 by, well, this is 2, so I think the rectangle is 5 by 4. We can see the radius in the circle is 2 meters. These are all meters. Now, the hard part, and you got to catch that the rectangle is not 7. 7 is this whole way. The rectangle is only 5. So how far is it here? Well, if this is 5 up top, you have to catch that that's 5 meters there. That leaves 2 meters. And if this is 4 meters, this has to be 4 meters. Well, now it's just simply filling in for the variables. When I replace a variable, I use parentheses. 2 meter base times 4 meters plus 5 meters times 4 meters plus 1/2 pi 2 meters squared. 2 times 4 is 8, times half is 4 meters squared. 5 times 4, 20, and meters times meters, meters squared, plus, and I'll wait on this, half times pi, and remember 2 meters squared, it means 2 meters times 2 meters. We repeat the inside. 2 times 2 is 4, so I have 4 meters squared. 4 plus 20, these have the same term, so I'm going to write this as 24 plus half times 4 is 2 times pi is 2 pi meters squared. And that's where I'm going to stop. 24 plus 2 pi meters squared. You cannot call this 26 pi. Remember, they have to be the same. This is counting how many pi's there are. This is just a number. So you cannot combine these two terms. They're not like terms. Again, these are the basic properties of area. Basically, there are 3 equations for 2D shapes you should know off the top of your head. Area of a rectangle, length times width. Area of a triangle, 1/2 base times height. Area of a circle, pi times the radius squared.